Hi everyone, let us start with factors formulas. Okay, let us assume there is a number capital N in the form of prime factorized method. Means if I write n in the form of a to the power of p multiplied with b to the power of q multiplied with c to the power of r. So here a, b, c are unique prime numbers. See, I'll write here where a comma b comma c are unique prime numbers. Unique prime numbers. Okay, so whenever I write any number in this format, that type of format is known as prime factorized method. So if I take an example of number 20 here, 20 can be written as 4 5s, right? So 2 square multiplied with 5 to the power of 1. So if you observe here, 2 and 5 are unique prime numbers. Okay, so the very first question is total number of factors. So how to find the total number of factors of this number n, total number of factors of this number n. If you observe the powers here, p, q and r, add 1 to each power and multiply. See here, p plus 1 multiplied with q plus 1 multiplied with r plus 1. Okay, now if you take this number as an example, total number of factors of 20 is nothing but here powers are 2 and 1, right? So 2 plus 1 multiplied with here 1, 1 plus 1. So we have 3 multiplied with 2. So we got answer 6. So 20 has total number of factors are 6. If you want, I'll show all those 6 factors. See here. Factors of 2 square are nothing but 2 to the power of 0, 2 to the power of 1, 2 square, right? Factors of 5 power 1 are 5 power 0 and 5 power 1, right? As you already know, 2 power 0 is 1 and 5 power 0 is also 1. If you observe here, 1 multiplied with 1, we got 1 factor. 1 multiplied with 5, we got another factor. And the next factor, you are multiplying 2 with the same set of 1, 5, right? So just simply multiply 2 with this 1 and 5. 2 ones 2, 2 fives 10. So we got another 2 factors. Same, 2 square multiplied with 1 and 5, right? So simply multiply 2 to this set, 2 twos 4, 2 tens 20. So these are the 6 factors of 20 here. So we got 1, 2, 4, 5, 10 and 20. These are the 6 factors of 20 here. Remember one more point. These are the positive factors of 20, right? So the negative factors minus 1, minus 2, minus 4, minus 5, minus 10 and minus 20 also divide the number 20 here. Okay. So in the examination, if they ask like total number of factors of n, we just consider only positive number of factors. Okay. So if they ask the question like total positive factors, if they ask like total positive factors, simply number of factors of n. In this case, let me change the pen. In this case, number 6 here. Okay. If they ask the question like total negative factors, total negative factors. See how many positive numbers are there? Those are same number of negative factors also. So in this case, same number 6 also. So if they ask the question like total integral factors, see total integral factors, total integral factors. Total integral factors is nothing but total positive factors plus total negative factors, total negative factors. So in this case, in the example of 20, total positive factors are 6 and total negative factors are same, right? 6. So we got total 12 integral factors here. Okay. Let us use another question here. So if they ask like total prime factors, total prime factors, total prime factors. See, total prime factor, simply add the powers here. Means in the case of n, so we have power p, power q, power r, right? So now if you observe in the example case, total prime factors if they ask, simply add the powers. 2 plus 1. See here, 2 plus 1. So the total prime factors are 3. But if they ask the question like total unique prime factors, see this question. If they ask like total unique prime factors, unique prime factors, unique prime factors. In the case of 20, if you observe here, in the case of 20, unique prime factors are 2 and 5, right? So, in examination, if they ask question like total unique prime factors means simply number of unique prime factors. So, here we have 2 in this example. Those are 2 and 5. Okay. So, and the very good question now is if they ask like total composite factors. See here, total composite factors, total composite factors. As you already know, what are composite numbers? The numbers which have minimum 3 factors. Remember, minimum 3 factors are composite factors. So, they don't need to be prime factors because for prime factors, one and itself, right? But for composite factors, there should be minimum 3 factors. So in the examination, if they ask like, what are the total composite factors? Simply total factors minus total unique prime factors, total unique prime factors and minus 1. See here, why did I do minus 1 here? So if you observe here, in the factors list of 20, we have 1, right? But in the what they asked this question, total composite factors, we already know that one is neither prime, neither prime nor composite. So we need to eliminate number 1. So I subtracted 1 from here. Okay. So if you observe here, in this case of 20, total factors are 6, total prime factors are 2, so minus 1. So total we have 6 minus 3, 3 is our answer. Okay. Now let's see some other questions. So now let's see some other factors formulas on the same number. N equals a to the power of p multiplied with b to the power of q multiplied with c to the power of r only. These are very important. Try to listen carefully. Okay. See here. Here a, b, c are, you already know these are prime numbers. So if I take this a number as 2 here. See here. 2 to the power of p multiplied with b to the power of q and c to the power of r. As you already know, 2 is the only even prime number. So if this is even prime number, b and c are odd numbers, right? So b and c are odd prime numbers, odd primes. Okay. Now tell me, see here, tell me what are the factors of 2 to the power of p? You already know 2 power 0, 2 power of 1, 2 square, so on up to 2 to the power of p, right? Similarly, factors of b power q, b power 0, b power of 1, b power of 2, so on up to b power of q, right? Now same, similarly c power of r, c power of 0, c power of 1, c square, so on up to c power of r. See, now I want to find is total even factors, total number of even factors, total number of even factors. As you already know how to find total number of factors, right? We just saw in previous slide. Total number of factors, total number of factors, how do you find here? P plus 1 multiplied with q plus 1 multiplied with r plus 1. But now I want total number of even factors. See, listen very carefully. Tell me, when odd number multiplied with odd number, what is the number do I get? Odd number only. Odd multiplied with odd, you will get an odd number. So, when do you get an even number? So, I want even factors. So, I want an even number, right? So, when do I get an even number? When even number multiplied with odd number or odd multiplied with even, then only I'll get even number, right? In this case. Now, if you observe here, b power 0, c power 0 is 1 and also b and c are odd prime numbers. See, whatever power you do for an odd numbers, you will get an odd number only, right? So, this complete set, complete set are odd numbers. And also, if you see here, 2 power 0 is a 1. Didn't you get any doubt why I took only 2 power of p? See, I want to find number of even factors. If this is also some odd prime number, how do I find an even factors? You got my point, right? So I want to find even factors, so that's why I took some prime number is 2. Some prime number, not only one and only prime number, which is 2. So in order to explain number of even factors, I took a prime number 2. If there is no prime number of 2 only, then we don't need to find the even factors only, right? Okay. Now I want to find even factors for this number. Okay. So here if you want, if you see here, 2 power 0 is 1. 1 is a odd number. So if I multiply 1 with any of these numbers, I'll get an odd number. But I want even number. So if you see here, from 2 power of 1 to 2 power of p, how many factors? 1 to p. These are p factors, right? When these p factors multiply with any of these numbers, I'll get an even factor, right? See again, I'll repeat. When these p factors multiplied with any of these numbers, I'll get an even number, right? So when I am trying to find total number of even factors, I'll take, in this case, I'll take only p factors, but in these two cases, I'll take q plus 1 and r plus 1. This is the formula for number of even factors. Similarly, if they ask like total number of odd factors, see, odd factors. So I leave these p factors and I'll take only one here. If I take these, how do I get an odd factor? This, you are getting my point, right? So if I take only one number which is 2 power 0, then I multiply with, I'll get an odd factor. So here in this case, I'll take only one. I'll take q plus 1 and r plus 1. I hope you understood how I wrote total number of even and odd factors. Okay. If they ask like total sum of factors, not total, sum of factors. If they ask like sum of factors, if you observe here, sum of factors of this number, how to find? So a to the power of p factors completely you write a power of 0, a power of 1, so on up to a to the power of p, right? Now write b power of p q factors, b power of 0, b to the power of 1, so on up to b to the power of q. Similarly, c power r factors, c power of 0, c power of 1, so on up to c power of r. Okay. So if you observe here, I just scroll a bit. If you observe here, these are geometric progressions, right? See, we have a to the power of 0 to a to the power of p. We have total p plus 1 numbers. So, a into a means a power of 0, a power of 0, r a into r means common ratio a, n how much total numbers p plus 1 minus 1 by r means a minus 1. Similarly, b power of 0, b power of how many q plus 1, q plus 1 minus 1 by b minus 1. Similarly, c power of 0, c power of r plus 1 minus 1 by c minus 1. So here a power of 0, b power of 0, c power of 0 are 1. So if you remove those, the direct formula is a power of p plus 1 minus 1 by a minus 1 multiplied with b power of q plus 1 minus 1 by b minus 1 multiplied with c power of r plus 1 minus 1 by c minus 1. In exam you will not do this formula. Most of the people will use only this formula only. Okay, try to remember that only. So in the very next question, if they ask like reciprocal sum of, see here, sum of reciprocal of factors, if they ask like sum of reciprocal of factors, simply sum of the factors, simply sum of the factors divided by given number. Here in this case, number is capital N, right? So you might get confused on how I wrote these factors, means how I wrote these formulas. I'll take an example in the next slide, then you'll get complete idea. Okay, let's go for the next slide. Let's take a number, for example 1080. Okay, first let us write this in prime factorized method. 108 means 12 nines, so 3 times 4, 9 is 3 square. We already have 10, 2 times 5, so finally we have 2 threes, 2 cube, 3 threes, 3 cube, and 5 to the power of 1. So this is the prime factorization of 1080. So the first question is total factors. Our basic question, total factors how many? Total factors, we'll just do 3 plus 1 multiplied with 3 plus 1 multiplied with 1 plus 1. So 4 times 4 16, 16 times 2 32. So 1080 has total 32 factors. And the very next question is total even factors. Total even factors. What did I tell you for the even factor? Just write the number p without plus 1. So 3 multiplied with 3 plus 1, 1 plus 1. Or else I'll show why we should write 3 only. See, we have 2 cube multiplied with 3 cube multiplied with 5 to the power of 1, right? Factors of 2 cube, 2 power of 0, 2 power of 1, 2 cube and sorry 2 square 2 cube. 3 power 3 factors, 3 power 0, 3 power 1, 3 square, 3 cube. 5 power 1 factors, 5 power 0, 5 power 1. What did I tell you? When even number multiplied with odd number, we get an even number, right? Say 2 power 0 is 1. So when here, these all are odd numbers only, right? Odd power anything is an odd number. So when these, how many numbers? 1, 2, 3. When these 3 numbers multiplied with these, we'll get an even number. So that's why I took 3 here. Okay. Now see here, 3 times 4, 12. 12 times 2, 24. Total even factors, 24. So what are total odd factors here? How to find total odd factors? Just we have to take only number 1. See, we have only one factor, which is 1 here. So 1 multiplied with same 3 plus 1, 1 plus 1. You are trying to get right. Why I am writing directly? Okay, 4 plus 2, 8. See here, 24 plus 8 how much? 32. See, total number of even factors plus total number of odd factors, we get total factors. Okay, see here, sum of factors. How to find sum of factors? You can take the formula or you can directly add. See here, first add all these 2 power of 0 plus 2 power of 1 plus 2 square plus 2 cube multiplied with add all these 3 power of 0 plus 3 power of 1 plus 3 square plus 3 cube multiplied with add all these 5 power of 0 plus 5 to the power of 1. Okay, see here 2 power of 0, 1, 2, we have 4 here, we have 8 multiplied with 1, 3, 9, we have 27 here and we have 1 plus 5 here. So if you observe here, 8 plus 2, 10, 4 plus 1, 5. So we have 15 here. So we have 30 and we have 10, we have 40 here and we have 6 here. 15, 4, 60, 6, 6, 36. So 3600. So sum of factors is 3600. Okay. If they ask like sum of even factors, sum of even factors, same. So when you are finding total number of even factors, we took even numbers. In this case also, just take even factors for 2 because 2 is the prime, even prime, right? So neglect 2 power 0 here, 2 power 1, 2 square, 2 cube, same 3 power 0, 3 power 1, 3 square, 3 cube. Why? Because these are odd numbers. So even multiplied with odd, you'll get an even factor. So 5 power 0, 5 power 1. So here 15, we just took 1. So 14 multiplied with same here 40, here 6. How much we got? 14 fours, how much? 40 plus 16, 56. 56 6, how much? 336. So 336, we got 0. Now if they ask like sum of odd factors, you can subtract total sum of factors to odd factors, you'll get even factors, you'll get odd factors, or you can use simply sum of odd factors. Sum of odd factors. Here we neglected this number, right? Just take that number only, 2 power 0, and you take same, this complete, this complete. So 40 multiplied with 6. So this is 2 power 0 is 1, 4 6 24. So you got 240. See here, 3360 plus 240, you are getting 3600. Okay, and the one more question, if they ask like product of factors, product of factors. See here, for 1080 we got total 32 factors, right? If they ask like product of these 32 factors, simply take the number in the power number of factors divided by 2. See, what is the number here? We took 1080. Number of factors we got 32 divided by 2. So product of factors answer is 1080 by 1080 power 16. Okay, now let's see remaining formulas also. Now let's see a small concept. I'll tell you two statements. Remember very carefully. The very first statement, when there is a number in the form a to the power of n plus b to the power of n. Okay, when there is a case when n is odd. Okay, when the case n is odd, this number a power of n plus b power of n is perfectly divisible by a plus b. This is the first statement. And the next statement is same number when a power of n plus b power of n, in the case when n is even, when n is even, can't be determined. Can't be determined. I'll explain. Can't be determined. Okay. Now see a power of n plus b power of n. When this number divided by a plus b, let's see the both cases. The very first case when n is odd. Okay. See here. When a divided by a plus b, what is the remainder we get? Minus b, right? See, I'll show. Or else when a plus b, when a divided by a plus b, you'll get a plus b once a plus b. Okay, a minus of a plus b minus, you'll get minus b, right? Remainder. So in the place of a, I can write minus b, right? So minus b whole power of n plus b to the power of n divided by a plus b. See here n is odd, means you'll get negative outside. So minus b power of n plus b power of n divided by a plus b. So you got 0, which is a remainder. So what is the meaning of this? So a power n plus b power of n is completely divisible by a plus b when n is odd. Our first statement. Okay. Now let's check the remaining next statement. When n is even. When n is even case. Same. When n is in the place of a, I can write the remainder minus b, right? Minus b whole power of n plus b power of n divided by a plus b. See here n is even. So minus becomes positive b power of n plus b power of n divided by a plus b. I got 2b power of n by a plus b. So in this case scenario, remainder can't be determined. Remainder can't be determined. The very second statement. I'll say two more statements. Okay. Very interesting. See, two more statement. And the next statement is if the number is in the form a power of n minus b power of n. See, now the form is a power of n minus b power of n when n is odd. When n is odd, this number perfectly divisible. Perfectly divisible by now a minus b. Okay. And another statement, when the same number a power of n minus b power of n, in the case when n is even. When n is even, perfectly divisible by both a minus b and a plus b. I'll show, don't worry, I'll show. And the first case, when I take a power of n minus b power of n divided by a minus b. Okay, same. When a divided by a minus b, I'll take remainder b, right? Or else I'll show that also. See, a minus b, I divided a, same, a minus b once, a minus b, a minus b means I got remainder b, right? So in the place of a, I can write b, right? That's what I wrote. In the place of a, I wrote b power of n minus b power of n, a minus b, which I got remainder 0. So if you observe here, I did not say whether it is an even or odd. So whatever the value of n here a power of n divided by a minus b exactly. In the first statement, see, a power n minus b when n is odd divided by a minus b, a power of n divided by when n is even divided by a minus b. So whatever the value of n, a minus b, a power n minus b power of n is always divisible by a minus b. Now let's see a plus b scenario. You're understanding, right? Understanding, right? Okay. So now let's take scenario a power of n minus b power of n when divided by a plus b. Okay. Let me write a minus b, sorry, a plus b. The first case, when n is odd. When n is odd. Same. A divided by a plus b means I can write minus b, right? In the first case I showed how to write in the place of a minus b remainder minus b power of n divided by a plus b. Here n is odd, so I'll get negative minus b power n minus b power n by a plus b. So in the numerator I'm getting minus 2b power n by a plus b. So not determined. Not determined. See, don't confuse. We wrote the statement a power of n when n is even divisible by a plus b. I did not write when n is odd, so that's why not determined. Now let's see even case. Okay, even case when n is even. So in n is even, minus b whole power of n minus b power of n divided by a plus b. When n is even, you will get positive, right? B power n minus b power n by a plus b. So you got remainder 0. So a power of n minus b power of n completely divisible by a plus b when n is even. We saw both the statements. So if you want to remember, just try to remember like this. So when first case scenario, a power n plus b power of n, right? Let's take a number n value 3. If you take n value 3, a cube plus b cube. How to write a cube plus b cube formula? A plus b multiplied with a square minus ab plus b square, right? So if I wrote this a plus b in the denominator, I'll get like this, right? A plus b. So this a cube plus b cube is completely divisible by a plus b. We got some quotient when n is odd. In the case of even, you'll get, if you take 2, a square plus b square. There is no other formula you can just write in this form for a square plus b square. That's why that statement is false when n is even. So if you want for a cube, a power of n minus b power of n, you just take when same n is 3, you take 3 here. A cube minus b cube, you can write like a minus b multiplied with a square plus ab plus b square. See, when I write a minus b denominator, I'll get a minus b. A cube minus b cube completely divisible by a minus b when n is odd. Now if I take even, if I take 2 here, a square minus b square, I can write a plus b multiplied by a minus b, right? Say I got a minus b and a plus b. So if I write each one denominator, so a square minus b square is divisible by a plus b and a minus b. So if you want to remember like this, remember, or you can directly remember. Okay. One more sweet concept here. I'll write with another pen. See, when three consecutive numbers, let's say for example, n, n plus 1, n plus 2 are three consecutive numbers. Try to remember, very important, when three consecutive numbers are there, it's completely divisible by 3 factor always. Okay, means three consecutive numbers are always divisible by 3 factorial. Similarly, if there are four consecutive numbers n, n plus 1, n plus 2, n plus 3, like this, if there are four consecutive numbers always divisible by 4 factor, like this, 5 consecutive numbers 5 factorial, 6 consecutive numbers 6 factorial, and so on. This is very good concept. Okay, now let's see remaining concepts also. Now everybody's favorite topic in number system is remainder concept, right? Let's see some points in remainder concept. Okay, the very best basic mantra of remainder concept is dividend equals divisor multiplied with quotient plus remainder. Okay, basic mantra everybody should remember. Now, and one more small inequality is divisor is always greater than remainder. Okay, this is very good inequality. Try to remember this, and you already know the basic ones like when x plus a whole square divided with x, the remainder is based on a square divided by x. So the remainder will be based on a here, or else you can say like x plus a power n divided by x means a power of n. I think you probably know this, or else if there is like x minus a whole power of n divided by x here, if n is odd, so if n is odd, we'll get minus a to the power of n divided by x. If n is even, if n is even, you probably get a power of n divided by x. But we'll see some other points, not these basic ones. We'll see some other points. Okay. The very first point is 2 power of odd. When there is a number 2 power of odd, when this number is divided by 6, we'll get, in every case, we'll get remainder 2 only. Okay. Similarly, 2 power of even when divided by 6 will get 4 remainder in every case. Okay. If 4 power even or odd, let's take n here. Either n even or odd, when 4 power n is divided by 6, you'll always get remainder 4 only. These are the basic lines. If these are remembered in your brain, in examinations it will be easy to solve. Okay. Or you can take the example, if I take n value 1, which is an odd number, 4 by 6, we got remainder 4 here. Or else if I take even, let's take 2, 4 square by 6, how much? 16 by 6, we got remainder 4 here. Same. Okay. You already probably heard the name totient function, right? Totient function. So no need to remember the name, but just remember the usage of it. So what is the formula of totient function? If there is a number n, the totient of n, how much? Phi of n equals n multiplied with 1 minus 1 by p1 into 1 minus 1 by p2 into 1 minus 1 by p3 and so on, right? Where p1, p2, p3, what are these? These are unique prime factors of n. Unique prime factors of n here. Okay, let me take an example, you'll understand. If there is a number 12 here, what is the prime factorization of 12? 4 threes, so 2 square multiplied with 3 to the power of 1. So if they ask what is the totient function of 12, phi of 12 is nothing but number n multiplied with 1 minus unique prime number 1 by 2. 1 minus, here unique prime number is 2 only, right? So 1 minus 1 by 3. So 12 multiplied with 1 minus 1 by 2, 1 by 2. 1 minus 1 by 3, 2 by 3. 6, 6 twos, 2 twos, 4. So phi of 12 is 4. But what is the use of this number? Means what is the use of this totient function? Means it basically uses about in cyclicity concepts. Means for how many numbers the same reminders will be repeated. Means if there is a large powers, so with what number we need to divide with the, we not divide with the power. Here 4 we got, means for every 4 numbers same reminders will be repeated. Means for 4 numbers, if a b c d are reminders, for the next 4 numbers also the same reminders will be repeated. So basically totient function will say cyclicity of that number. Okay. And there are some other two small concepts. This keep the name Fermat theorem and Wilson theorem. No need about the name. Just see, if any number is in the form n power p minus 1 by p here, where p is prime number. Okay. Where p is a prime number, when any number is in this format, the remainder is always 1. Remainder is always 1. Just remember. So any number in the form of n power of p minus 1 by p, where p is a prime number, the remainder is always 1. If you want, I'll give an example. Here 16 power 18 by 19. See here, n power p minus 1, here p. N is a prime number, here p minus 1. So our remainder is 1 only. So here I forgot to say one point here in totient function. An exception, not a point, one exception. See, generally if you do phi of 100, you will get a totient function 40. But basically for every 20, the reminders will be repeated. So in during examinations, when you are taking phi of 100 of a totient function, take 20, not 40. Okay, this is an exception. Just remember. Okay. when you got, just remember this concept. Now the very next is we said n power p Wilson format, right? No, Wilson, same. If any number is in the format p minus 1 by p, here p minus 1 factorial. So if any number is in the form p minus 1 factorial by p, then the remainder is always minus 1 or p minus 1. Okay, directly you can write. If I take an example like 2 factorial by 3, see here, this is p, this is in the form p minus 1, you can directly write 2. 2 is the remainder here, like that. Okay, now I think you probably all know the cyclicities here. So 1 power anything, you'll get 1 only. Here 2 has the cyclicity of 4, means powers repeat for every 4 numbers, for every interval of 4, and for every interval of 4. Try to remember that. Similarly for 3 also, cyclicity is 4 only. For every 4 numbers, the powers will be repeated. For 4 there are two things, means if 4 power of odd, the remainder unit digit will be 4, or the remainder is 4. 4 power of even, the unit digit will be 6. Okay, for 5 power anything, you'll get unit digit 5 only. 6 power anything, you'll get unit digit 6 only. And for 7, 8, for these two, the cyclicity 4. Remember, for 2 and 3 the cyclicity is 4. For 7 and 8, cyclicity 4. For every power of 5, you'll get unit digit 5. For every power of 6, you'll get unit digit 6. For 4, 4 power odd is 4. 4 power even, you'll get 6. Now similarly for 9 also, 9 power odd, the unit digit will be 9. 9 power even, the unit digit will be 1. As you probably already know, 0 power anything, you'll get unit digit 0 only. Okay, next concept. Okay, now let's see some numbers here. Let there be a number capital N. If 7 divides this number n completely, and also 13 also divides this number n completely, then the LCM of 7 and 13, which is 91, this 91 also divides this number n completely. Or else see in reverse, means vice versa. If 91 divides this number n completely, then that number n is completely divisible by 7 and 13. You are getting my point, right? Now let's see some other numbers. If any number divisible by 7, 13 and 11, that number is also divisible by 1001. This is very important. Try to remember, when any number is divisible by 7, 11, that number is completely divisible by 1001, and vice versa also. Okay, now let's add one more number, 7, 13, 11, now 37. Then that number is completely divisible by 37. Now let's add one more number. When any number divides with 7, 13, 11, 37 and 3 also, then that number is completely divisible by 111. Now a small one, if any number divisible by 3, 7 and 11, then that number is completely divisible by 231. Now if any number divisible by 3 and 37, that number is completely divisible by 111. These are the very important combinations you should definitely remember. Okay, these are the very important, you have to remember. They kept some name for this, combined divisibility rule. You don't need the name, you just need the what are the numbers. So try to remember these numbers. Okay, in these numbers, see this number 1001 here. So 1001, there will be a number 101 also, right? If any number is multiplied with this 101, let there be a capital A. If 101 is nothing but 100 plus 1, right? So if any number is multiplied with 101, the form of that answer will be repeated with 2 digits. So when A is multiplied with 101, the answer will be in the form 0A, 0A. 2 digits will be repeated. Or else if 101 multiplied with any number AB, then the form will be AB, AB. 2 digits will be repeated. Like that, if any number multiplied with 1001, okay, 1001, then what is the representation of that number? 1001 is nothing but 1000 plus 1, right? Here, three digits will be repeated, which means the answer will be in the representation form 00A 00A. Okay. Similarly, if 1001 is multiplied with AB, same three digits 0AB 0AB. Okay, like that. Similarly, let me scroll down. Similarly, if any number multiplied with 10001, then 0001 is nothing but 1000 plus 1. So the four digits will be repeated. So if any number A, B, C, D is multiplied with 10001, the answer will be the form 4 digits. A, B, C, D, A, B, C, D. Okay, I'll tell you a small important one. Let's say, for example, there is a number. Let's take 5, 8, 6, 2, 7, 3, 1, 6, 8. Let's add two more, 9, 2. You tell me, guys, whether this number is divisible by 1001 or not. So you can see, as you already know, 10001 is nothing but multiplication of 7, 13 and 11, right? So you can check whether this number is divisible by 7, 13 and 11. Then you can say whether this number is divisible by 1001, or else you can see one more thing. See, 1001 is just now we saw 1000 plus 1, right? Three digits. Now from the right side onwards, see, from the right side onwards, divide this number completely in three digits. 1, 2, 3. Okay. 1, 2, 3. Okay. 1, 2, 3. Okay. So these are the four sections, right? If I give numbers, number 1, number 2, number 3, number 4. Same. How we will do the 11 divisibility rule? Odd places minus even places, right? Similarly, odd places plus even places. So 4 plus 2 minus 1 plus 3. Okay. You guys tell me whether this number is solving with 100, means the resulting number after subtracting you will get a resulting number, right? If the resulting number is divisible by 10001, then the complete number is divisible by 10001, or else it is not divisible by 10001. See, now you guys tell me what is the reminders when 7, 13, 11 are divided. This number means when this number are divided by 7, what is the remainder? When divided by 13, what is the remainder? And divided by 11, what is the remainder? Okay. Now let's see some more divisibility rules. These are very important. Next slide. See, now I think you probably already know the divisibility rules of 2, 3, 4, 6. Those are. Now let us see the divisibility rules of 9, 99, 999, 9999, like that. Like these type of numbers. Okay. Let me take a number as an example. Let's take 14638. Now first let us take the divisibility rule of 9 here. You probably already know. Sum of individual digits of that number. If though the resulting number is divisible by 9, then the whole number is divisible by 9. Okay. 1 plus 4 plus 6 plus 3 plus 8. See, 10, 19, 19 plus 3, 22, 2 plus 2, 4. So we got a number other than 0 and 9. So this number is not divisible by 9, and this 4 is also remainder when this number is divided by 9. Okay, now let's see the divisibility rule of 99. Same, let's take the same example. 14638. Here, when we have 19, we added individual digits, right? Now we have two nines here. Now let us take two numbers from the right side onwards. Okay, so there is no number. So let's take 0, two numbers. Now add these numbers 0, 1 plus 46 plus 38. How much? 47 plus 38, 47 plus 30, 55, 85. 85. So 99, when this number is divided by 99, we got 85, which is the remainder. So this number is not divided by 99, and this 85 is the remainder when this number is divided by 99. So when in case of 99, two nines, take two digits from the right side and add those numbers. If the resulting number is divisible by 99, then whole number is divisible by 99. Okay. Similarly, 999 also. Here, three numbers are there. So same number will take 14638. Now we'll take from the right side three digits. 014638. So if we add here 8 plus 4, 12, 1 carry forward, 4, we got 5, we got 6, 652. When when this number is divided by 999, we are getting a 652 which is less than 999. So this is the remainder here. So when this number is divided by 999, we got a remainder 652. Similarly, if there are 4 nines, you'll take 4 numbers and so on. Okay. I think you probably already know the divisibility rule of 7, right? Divisibility of 7. No need to explain this one. Basic procedure is good, but I'll explain. Okay. Just listen. But most in examination, I think this is not a better approach, but listen, this is also there is a one more approach for the checking the divisibility rule of 7. So let me take a number as an example. Let's take 1462. So if you see directly, this number is not divisible by 7, but if there are large numbers, means 2 6 4 7 7 7 like that, how to check the divisibility of 7? See, take the except last unit digit, take the remaining digits 146. Now subtract 2 times of last digit. Here last digit is 2. So 146 minus 2, 142. Now directly you can see whether 142 divisible by 7, or else you can go one more step, like accept the last digit, take the remaining digits 14 minus 2 times of now the last digit 14 minus 4, we got 10. Now 10 is not divisible by 7. See, when here when 10 divided by 7, you get a number 3. But this is not the remainder when 7 divided with 1460. I mean, this number is divided by 7. Only this procedure only tells us whether the number is divisible by 7 or not the remainder. So that's why I don't recommend this method, but just understand, okay? While doing this approach, the resulting number is not the remainder of this number when divided by 7. Similarly, I'll say this one also. Remember, divisibility of 11. You probably all know this one, but let me explain. This one important thing here. Let me take a number as an example, 378. I'll take one more, 3782. Okay. Most probably, what you will do for checking the divisibility of 11, you will check the odd places minus even places. If the resulting number is 0 or 11, then it is divisible by 11, or else not. Same, if I do see check 3782. If I take odd places from left side onwards, see from left side, let me check another pen, from left side, okay, left side onwards, 3 plus 8 how much? 11 minus 7 plus 2 how much? 9. 11 minus 2, we got a number 2. Then we can say that this number is not divisible by 11. But is this 2 is the remainder of this number when divisible by 11? No. When this number is divided by 11, 2 is not the remainder. So when this number is divided by 11, you see 11 3 is 33, you'll be left with 48, 44, you'll be left with 42, 33. So you got a remainder 11 when divided by this number by 11. But you got this number 2 while checking the alternate places. Now without means I'll tell you same procedure, take the number 3782. Now make it acquaintance, make it a habit of seeing from right side onwards. Divisibility of 11. This is very useful. Why? Because see, you will only know 2 plus 7. 2 plus 7 means 9 minus 3 plus 8, 11. You got minus 2. Minus 2. When minus 2 the remainder, we'll do add with the divisor, right? 11 minus 2, we got 9. From this 9, we can say that this number is not divisible by 11, and also 9 is the remainder of this number when divided by 11. See, one beautiful. So, whenever you try to see whether is a number is divisible by 11 or not, make sure you see from right side onwards. Why? Because you can directly say the remainder and also whether it is divisible by 11 or not. I hope you understood why I said the divisibility of 11 here. Okay. Now a very small concept. I think you already probably know this. They'll say like digits concept. Okay. Not unit digit concept. They'll say some digits concept means from 1 to 9, how many digits we have? 9 digits, right? Okay. From 10 to 99, how many digits we have? See, from 10 to 99, how many numbers? 90 numbers. In each number, we have 2 digits. So, from 10 to 99, we have total 180 numbers. Now, 100 to triple nine, 100 to triple nine. See how many numbers? 900 numbers, right? 900 numbers. In each number you have 3 digits, 3 digits, total 2700 digits. So remember this point, from 1 to triple nine, total digits we have, add all this. So you have 2889 digits. Okay, this is a very important one, try to remember please. Okay, and they'll say in 1 to 99, every digit will repeat 20 times. Remember, in 1 to 99, every digit will repeat 20 times. Okay. So
Next.
that's all for this video, guys, and please guys, please to like our video and share with your friends, and PDF of this session will be uploaded on our Telegram channel. Make sure to join our Telegram channel. So see you in the next video. Bye.